We're going to start to actually work with our linear equations now. Initially, I gave you two formulas for your notes, so we're going to be concentrating on the standard form of it, of ax plus by equals c. In this standard form, there's a very cool way that you can find your points in order to draw your line on your graph paper by using that formula. We're going to be choosing points, plotting the points on a graph, and then just connecting the dots. I've lined up my equation to the formula where a is the 2, b is 3, and c is 30. That's our equation. Now the values for x and y can vary. That's why they're called variables. And they can easily be done on a t-graph like this, where we're lining up our x and our y. If we choose a value for x to be 0, the math is quite easy because this part of it is completely gone. Now we have 3y equals 30. So 3y is equal to 30 is pretty easy to do. In fact, you probably could do it in your head. Y is equal to 10. Now let's take away this variable completely by wiping it out with a 0. So we're going to put a 0 for the y term. Anything times 0 is 0, so this term gets blotted, and our equation now looks like this. 2x equals 30. Divide by 2 on both sides. X is equal to 2 goes into 3 one time with 1 left over. 2 goes into 10 5 times. So in this case, our x is equal to 15. You really only need 2 points on to make any line. So we could graph this right now. Having zeros as a y and an x portion is called intercepts. In this case, this is the y-intercept, and this is the x-intercept. So when we graph this on a piece of graph paper, we would have 0, 10. So this is our y, and this is our x-axis. So we would have to go up 10 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the dot is right on the line because that's the point at which the line hits that y-axis. It's called a y-intercept. And on the x-axis, we're going to go out 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and place a dot there. Now all we have to do is connect our dots, and we have made the line. This line represents 2x plus 3y is equal to 30. It's a negative slope because it's going downward. Mostly it's into the quadrants because that line travels forever. I'll extend these, and you'll see that even though it went into quadrant number 1, the line most of the time would be into the 4th quadrant and the 2nd quadrant, which has ordered pairs of negative and positive for our x and y. And in this case, we have a positive and a negative for our x and y. So those give this a negative slope. Using the standard form with the x and y intercepts.